one says, differentiate this weird log function and then hence evaluate an integral. So here's the log function. Log of sec plus tan. They say differentiate that and hence evaluate. They give you a definite integral, this one. Okay? So, just off the face of it, you will remember, looking at this, right, that when we were integrating last time, we had integrals of sine, cos, tan, but then for your reciprocal functions, we didn't really have nice, neat ones that come out, okay? That's because they look really awful, like this. It's a bit like when you're integrating tan. What's the integral of tan? Do you remember that one? It also has a log in it. It's a log of what? It's negative log cos x. So this is a similar kind of situation. So let's differentiate and see what happens. This is chain rule for a log, right? So you've got this thing in here as your inside function, call it f, right? And so the derivative is just f dash on f, right? So let's go term by term. What are the derivatives? Sec turns into sec tan. Yeah, good. And of course tan just turns into sec squared. Great. That's f dash, and you divide by f, right? Okay. So this actually is quite a simple one because you can see on the top you can factorize, you can take out a sec, and that leaves you with tan x plus sec x, which is exactly the same thing that you have on your denominator, right? So that's why you can cancel out, and you get sec, right? So when they talk about, this is what it says in the program, integrals that use the relationship between integration and differentiation. Here's what they mean. Okay? If I were to put these two, I should put them on the same line, really. Okay? This derivative is equal to that. And I'm trying to work out this integral. Okay? I'm going to take the integral of both sides with respect to these two limits. I was going to say domain, but that's the wrong word. Okay? So therefore, if I integrate both sides, what's going to happen? Well, the left-hand side, right? Because it's a derivative of something, when I integrate, I'm just going to end up with that something in or within the limits that I'm interested in, right? So you see I'm integrating the left-hand side with respect to x from 0 to pi and 4, okay? And then what you have here is the question, okay? So you can see I've done the same thing to both sides. That's all I've done. So now all that's left is to evaluate, right? And this is what I'm after over here. So I'll put this on the left-hand side. And you've got log of, here's my first term, log of sec pi on 4. Sec pi on 4. Well, sec comes from cos, right? So cos pi on 4 is 1 on root 2. So you take the reciprocal, that's going to give you root 2, right? Sec pi on 4, tan pi on 4. Tan pi on 4 is a little easier. That's tan of 45, which is just 1. Okay, so there's my sec pi on 4, tan pi on 4. I actually don't need this first bracket. Okay, there's my upper boundary, so I'll subtract the lower boundary, right? Which is log of, now, sec of 0. Sec of 0, that's 1 on cos 0. What's cos 0? It's just 1. So 1 on 1 is 1. Then I've got tan 0, right, which is just 0. Okay? So yeah, you've got log of 1 here. That's log base e of 1, right? And you think, okay, this means what power do I have to raise e to? E to the power of something gives me 1, and the answer is 0. Okay? So this whole thing on the right-hand side disappears as well. Ta-da! There you go. That's all it is. All right? Evaluated. Often you'll get things like this. You'll have to differentiate something and then go backwards. Sometimes, when you differentiate, you get, say, for example, I'll get another colour. Suppose, just fictionally, right, if we were to differentiate, suppose there was a 2 out the front after we simplified, okay? Therefore, if I was asked to integrate this, okay, because this is not in the form that I exactly want it, you'd need a 2 there, right? Well, you just throw a half out the front. You're used to this kind of thing to compensate, right? So just be careful. What you get as a result after differentiating might not be exactly the same as what they want you to integrate, okay? So just take account for it, okay? All right, I should get rid of that because that's wrong. That's not what it's equal to.